Now we're going to be graphing what's called rational equations. We're going to do section 9.2. Let's dissect this word rational. Rational numbers. What root word is there? Ratio. What is a ratio?
It's an amount of something to the amount of something else.
How do we write it when we write a ratio?
What's it called?
Fraction.
A fraction. That's all this means. A fraction.
Oh.
Okay. That's all it means is fraction. So we're going to graph equations with fractions. That doesn't mean that we're just going to have 1/2 in there. That means we're going to have x in the numerator and denominator, but at least for sure in the denominator. This is what I want you to do. I want you to get your graphing calculator, go into y equals, and make sure that there's nothing in there. And you're going to put y equals 1 over x, and I want you to see what it looks like. All right, so this is what you got when we graphed it. I'm going to just tell you that it goes through 1, 1, and negative 1, 1. And then it kind of gets a curvy like this and a curvy like this. All right.
It looks like they come up and...
Yours look like they even touch the x and y axis, doesn't it? So I want you to do me a favor. I want you to see what happens if you change that 1 to a 2. I don't want you to, but I want two equations. So I want your y2 to have 2 over x and see what happens. So I want you to have both the graphs on and so you can see what it does.
Ooh.
So if I did a different color here, would it be out here or would it be in there?
It would be on the first.
Would it be the A one or the B one?
A.
It'd be A. So the 2 makes it spread out a little more, okay? That is correct. So it'll be that one in there, okay?
Yeah.
All right. You with me so far?
Yes.
Okay, so now, what would happen, do you think, if I added a 1 to the x? Just predict what's going to happen compared to this first one. What's it going to do to the second one, you think?
Go down.
He thinks it's going to go down. Is that what anybody else?
Like here's this, it'll go inside of it.
Oh, you think it's going to, we had this a moment ago. We had that, correct?
Yes.
And you think it's going to do what?
Inside.
Or you think it's going to come in
Do the same
here?
thing. Yeah.
All right, any other hypothesis?
Or be a negative.
Or me a negative?
And it'll be like,
Not a clue.
I think it may shift.
You think it may
Up or
shift,
down.
up or down. Okay, so up or down. So why don't you do it? When you put in your calculator, make sure you put parentheses. You're going to go 1 over, open parentheses, x plus
You
1
want to
close
leave the others?
parentheses. But keep this one
Oh.
as your reference
I
to
can
see what
put it
this
right
one
now.
did. Okay.
See, it just kind
Shift
of
over. Yes.
You just shifted over.
Shift it over towards the positives or the negatives.
The negatives.
Does that make sense to you that it should have?
Yeah. The opposite thingamajig.
Yeah, it's the opposite thingamajig, right? When you do something to the x, it goes up and down or left or right, and this one happens to left and right, and it just shifted it back, correct? Okay, so over on this one, we had an asymptote. I'm going to just tell you right now that your asymptotes are the x and y axis.
let's go.
You have to do sound effects. You have to. It just doesn't
You
work.
have to.
Okay, so on this new one, where's the asymptote?
-1.
At the -1 on the x or the y?
On the Y.
Over here, correct? So it's going to come back
No clue.
here, right? Because it scooted it back. What about the horizontal? Does it have it
Still on the x-axis.
still on the x-axis, correct? And it's still, by the way, it's kind of like at the 1, 1 and the -1, 1 of that new one. All right. All right. Let's do a hypothesis of this one. What do you think is going to happen compared to the number 1? What's number 3 going to do?
Scoot up.
You think it's going to scoot up?
Yes.
So I want you to get rid of this graph, the number 2 graph, and I want you to keep the number 1 graph and graph this one. Do you put a parentheses anywhere on this one?
1 over x.
You could, but you don't need to. You can just do 1 over x, then plus 1. I heard that someone say that it thinks it's going to go up.
It did.
So before, our asymptotes were the x-axis and the y-axis. Which asymptote changed, the horizontal or the vertical?
The horizontal.
The horizontal, did it go up or down?
Up.
Okay, so it went up 1, and it stayed, the vertical stayed here, and we still kind of have the 1, 1 and the -1, 1 of that new kind of like axis. And here is our graph, okay? And I told you not to draw them yet, so you're fine. We'll have plenty of time to do that. We haven't even named what these graphs are called. We know what parabolas are, we know what polynomials
They're
are.
called
All right, here we go. What are rational equations? Here we go. You'll want to write some stuff down from vocab. A rational function, first of all, the functions are written as a fraction with x in the denominator. For example, this one. This is a rational function because x is in the denominator. It does not mean that x cannot be in the numerator also, but it will definitely be in the denominator. The shape that is graphed is called a hyperbola. We've had parabolas. Now it's not a hyperbola, it's a hyperbola. Just like it's not a parabola, it's a parabola.
I love this word a lot. It's beautiful.
Hyper.
It's so cute. Hyper. Say it again.
Hyperbola.
That's
Hyperbola.
Not hyperbole, because there's that in English, but it's a hyperbola. All right, see, here we go. This is what we had drawn before. We saw it looking like this, correct?
Bola constrictor.
It's got two of them, and it looks like it's two things, but it's really all one graph. This says if I bring the x up here, if I brought the x up and I would say xy equals 1, this is asking what numbers multiply to be 1. That's why it's 1, 1. And if you came out here to 1/2 times 2, you'd have the next one, and so forth, and 1/3 times 3, and 1/4 times 4, and 1/5 times 5, and so forth as you go out. That's why the negative times negatives is going to also equal a 1. You're going to get these over here. All right, we have asymptotes. For this one, the horizontal asymptote is on the x-axis, and the vertical is the y-axis. And you're going to just have shifts about that. Shifts up and down, left and right from there. We eased you into this whole asymptote idea. You had one asymptote previous to this with your exponentials, and now we have 2 with the hyperbolas. So now let's do this. Let's actually graph this, okay? I want you to also tell me where the asymptotes are, okay? So we're going to graph it. I would suggest, at least for right now, 1, 1, and -1, but it's not going to be, you're not going to have necessarily points for all of them in the future, but at least you know those for this one. And you're going to get closer and closer to the x and y axis. This is number 1. And my vertical asymptote, I'm going to just write the word vert for vertical, is an equation. And a horizontal, my vertical asymptote, the vertical one is a y equal or an x equal? Okay, let's just do this. If I did vertical lines, are these verticals, are these x equal lines or y equal lines?
X equal.
These are x equal lines. So this one right here is what?
Vertical.
That's vertical, and it is a x equal. The y-intercept is a equation of x equals 0. What about the horizontal?
That's one.
That's y. Yeah. All right. So we've got number 1 with just that. We're not finished with number 1. If you notice, there's more to it. We're going to talk about that in a minute. We're going to try to find some fast ways to find those. Right now we have that. Let's go to number 2. We said that this was going to move it up, down, left, or right. My asymptotes go here to the side. I like to draw them, though. The horizontal stayed, though, correct?
Yes.
Okay. All right. And I still have kind of like the 1, 1 like that. And then I'm going to draw I'll do the little V for vertical asymptote and H for horizontal asymptote. Remember, we're going to try to see if we can just look at the equation to know the vertical and horizontal asymptotes. Vertical is x and horizontal is y. For this one over here, this is the vertical, and it should have been x equals,
-1.
Wait, that's not the.
Because it's going through the.
this is horizontal, and it should be y equals 0. And x should be x equals -1. Did we say that moved it up, down, left, or right?
Oh.
Up.
Now this one I'm sure. Why not?
You moved it down or up?
Down.
I heard up. I heard down.
Up.
It's up. Yeah.
The ones that when we add to x and y are the opposites, but the ones that we just add out to actually, in a sense, to the y value, it's the same. So this is moving it up. And the the vertical stayed the same.
Oh, it looks so right angle.
All right, now we're going to do our vertical and horizontal asymptotes. Vertical is x and horizontal is y, right?
X equals 1.
X equals, is this the x equal 1 line or is that the y equal 1 line?
That's the y equal.
That's the y equal.
That makes sense.
Okay. All right.
It made sense when it didn't make sense.
So then, the quick way, there might be a quick way to figure this one out here with this.
Just the opposite.
She thinks it's the opposite. Okay. So how do we find the vertical and horizontal of this one? So
It would be positive 1, not negative 1.
the vertical is upright, and it's x equals 0, correct?
Yeah.
And y equals
Positive 1.
+1. Here's a general thing about the shifting. You guys already figured it out. I didn't have to really tell you very much. That a value stretches it vertically. And that h over here moves it left and right, and the k value moves it up and down. We already figured that out already because you noticed that from all the other things we had to do, okay? All right. So where is this going to shift? Up how much? Down how much?
It'll be
Up
up
four.
4.
Up 4, left or right?
To the
over-
left 3.
Towards the -3. Okay.
It's
All right.
opposite.
And that 2 is just going to stretch it some.
Yeah.
Your graphing calculator will help you do that part. Okay. Those are going to help you find your asymptotes when you're moving it. All right. More information about these rational graphs. How to find your asymptotes. Here's our quick way to find your vertical asymptotes without having to look at the graph. In case you don't have to graph it, they just ask you what the asymptotes are. You just make the denominator equal to 0 and solve for x. So a moment ago, we had f of x equaled 1 over x plus 1. So if you set the denominator, the x plus 1 equal to 0, then x has to be -1. That will be your vertical asymptote, x equals -1. Okay. The horizontal asymptote, you look at the up or down shift. Or, this is one that you could do, but it's not going to be as easy. You could substitute very large numbers in for x and estimate what y is. We'll talk about that in a couple days. Let's talk about domain and range. All right, the domain. The domain is going to be all the x values except for the vertical asymptotes. And the range is going to be all the y's that's covered in the graph, which is most likely going to be, usually it's going to be all the y values except for the horizontal asymptotes. I think once you look at your graph, you're going to notice that anyway. All right, let's do some. The instructions on your paper say to identify the vertical asymptotes, horizontal asymptotes. We have done that. The domain and range, we're going to do that now, and we've already sketched it. So based on the sketch that you've already made, these things do not touch the vertical and horizontal the vertical asymptotes and the horizontal asymptotes are the x and y axis. So if I was to come in here and draw these lines to figure out my domain, where would I not touch?
At 0, 0.
I would not touch at the x equals 0, correct? Mm-hmm. So my domain,
X is greater than 0?
my domain will be x not equal to 0 because it's everything except. So we've done vertical and horizontal asymptotes on number 1. We graphed it. Now we need to do domain and range. So range.
I'm still not sure I understand how it
Okay, so in this equation, I can put in every number into this x value. The only one I cannot put in is 0. 0 can never be in the denominator of a fraction or the whole math world falls apart.
Okay.
All right? And so it shows this right here that notice it will never be 0 here. You'll never get to this asymptote 0. So I can put in x can be any number except it cannot be 0.
What do you mean I'll never get to 0 there?
This graph, just like Isaac said, if I keep going and going and going and going this way, I'll never get.
No, it's like you said. I don't agree.
Actually, it's this direction. If I go up this way, I will never, 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 never get to the y-axis there. All right. What about the range? Remember, we draw these to figure out the range. What will I never, where will it not touch the graph if I draw a horizontal line?
0.
At 0. At y equals 0. So I will not have y.
Will it be 0, 0 or just 0?
Just 0. Y will never be. And actually, I think that not equal, I think in your symbols, they're a little more diagonal. Okay? All right, not as straight up and down
So
like
in
I have.
every single one, it's not going to hit 0.
Unless we shift. So let's do the next one. Excuse me, number 2. Your graphs where it's going to be moved over here. Here. Correct? Okay, so it's going to graph like here. We've graphed our asymptotes. We need to do domain and range.
So x
The domain-
is not equal to 1.
It's a negative 1.
The domain is all the x values. That's these go like this, correct? So it's, yes, y should be x does not equal 1.
Negative 1.
Negative 1. Very good.
Oh, I feel so smart. when
Good
you do
job.
that
Good
problem.
job. And the range, y,
It's not equal 0.
yes. Now I want you to notice something. For the domain, it's going to be the opposite of this in here, just like the asymptote was. It's going to be this equal to 0 and solve for x. What about number 3? Number 3, we're going to move it up 1.
And because you move it up 1, x
So
will
then,
not hit 0, but
Yeah.
y will hit
1
1.
will not equal 1.
Yeah, will not hit.
Negative 1.
and our domain will be
You're right.
x, and our range is y. And for our domain, my domain is going to be
Not 0.
not 0. And our range will be not
1.
1.
Because it never hits it.
Correct, because it never hits it.
Okay.
Okay?
So basically, it's just not equal to our asymptote.
That's correct. That is
That
correct.
would've helped.
It's
How
be
is it gonna
down
shift?
1 and over 1.
Down 1 and over 1, I heard. Over 1 towards the left or the right?
Right.
Okay, so it's going to be down 1. I like to draw my asymptotes, but I like to do them in red. All right, so I down 1 and over 1 to the right.
No, wouldn't it be up 1?
This part here, the negative 1 on the outside right there moves it down. And this moves it in the opposite, because the ones next to the x's move it in the opposite. So this one, instead of moving it towards the negatives, it's moving it towards the positives. What does that 3 do to it? Just stretches it out a little bit more, okay? So it's going to take a while to get there. I'm not going to have you worry even about that 3. I'm just going to ask you to draw your hyperbola.
Where do we dot them?
Don't worry about it. Don't even worry about a dot right now. All right, so we need vertical and horizontal,
This bothers me.
and we need domain and range.
Positive 1.
So this is the vertical asymptote. This is an equation of
X equals 1.
x equal 1.
Y equals negative 1.
And my horizontal, y equal negative 1.
Negative 1. And then the domain is the same thing that we've been doing?
Yes. So my domain,
Not equal 1.
Yeah.
that's correct, with the not equals. That's correct. So my domain goes with these, I always make those little vertical lines, right,
Y
up
does
here.
not equal negative
And it doesn't go through that asymptote, so it's x does not equal what?
1.
1. And the range is,
Y does not equal negative 1.
so what goes with what up here? These have like a partner down here, don't they?
Yeah.
The vertical goes with the
Domain.
domain, and the horizontal goes with the range. Okay, all right. All right, so this is what we did. You graphed rational equations. You found their asymptotes, you found your domain and range. When we got all done, we went, oh, it's not so bad, but as we were going, there's a little bit of like brain work to do, okay? I hope this has been helpful. Goodbye.